So today we're covering 3.2. We're going to investigate slope and y-intercept using technology, which you should have already done. We should have already completed a graphing calculator investigation together. You should be able to, at this point, use a graphing calculator to graph a line and determine the y-intercept. You should be able, later, by the end of the period, you should be able to identify the slope and y-intercept from an equation, and you should be able to write the equation of a line from a graph. You should have also finished your Minds On for lesson 3.2, and if you haven't done that, please do that now. Okay, so I noticed yesterday that a lot of you hadn't finished your consolidate. If you haven't finished your consolidate from 3.1, please again pause the video and do that now. All right, so the slope of each line segment. So you can see there's 3 separate line segments here. So I'm going to find the slope. I'm going to use little m for slope. The slope of line segment A, first of all. So I'll just change the color here. And I'm going to draw my triangles. So I'm going to start at the bottom. And remember, do the rise first. So I'm going up to the height of my B, and then I'm going across. Oh, whoopsie. Overshot the runway. Let's see if we can undo that. I don't know. Edit, undo writing. Oh, there we go. Okay, so we're going to go 1, 2, 3, 4, 5, 6. So we're going up 6, which is up. So it's positive 6 for our rise. And we went from here and we went right 2, which is again positive. So the slope of A is 6 over 2, which simplifies down to 3. 6 divided by 2. All right, the slope of B, again, I'm going to draw another triangle. Now this time maybe I'll start at the top and go to the bottom. So I'm here, I'm going to drop a line down here. Remember, we're doing rise first. And rise doesn't mean we're rising. Sometimes we're falling, and that's okay. And then we're going right. All right, so I know that for the slope of B then, it's rise over run, and I'm actually going down 1, and right 1, 2, 3 squares. So right is positive 3. So there's my slope, negative 1/3. And the last one, I'm going to find the slope of C. So that's going to be down and across. Down is 1, 2, 3. So I'm going down 3. That's negative, going down. And then right is 1, 2, 3. That's positive 3. And then we wouldn't leave it as negative 3 over 3 because negative 3 over 3 simplifies to negative 1. Okay? All right, did you get those all right? I hope so. That's definitely an expectation that we have, that you can determine the slope of a line segment from a graph. All right, so let's start the lesson. You remember y equals mx plus b from last year, and hopefully you remember that the m, so the number in front of the x, when you've got an equation in y equals mx plus b form, represents the slope of the line. I'll just call it slope. And b, the number after the x term, if it's in this form, represents the y-intercept. And remember, you should know y-intercept is where the line crosses the y-axis. And the y-axis is the vertical axis. All right. Conversely, if you're told the slope and the y-intercept, you can put them together and you can form the equation. So if I told you the slope was 3 and the y-intercept was 4, we could come up with the equation. All right, so let's do a few examples here. What is the slope and y-intercept of this equation? Well, this is in y equals mx plus b form, so I know that it's the coefficient, it's the number in front of the variable that represents the slope. So m is negative 2, so make sure you include the sign. Don't include the x, okay? Slope is just a number. It doesn't have the x attached. And then for the y-intercept, it's this part here, and you must include the sign in front of the number. So in this case, the y-intercept is negative 4, which means this line crosses the y-axis when y is equal to negative 4. All right, the slope of a line is 6 and the y-intercept is 7. Write the equation of the line. Super easy. Remember, we start with y equals mx plus b to come up with the equation of a line, and then we just fill in. So we know the m represents the slope, so that's going to be 6x plus 7. Okay. Okay, now they get a little bit trickier. A line rises 4 units for every 2 units it moves to the left. So we really do need, from that information, we have to figure out what the slope is. So I'm going to use m again for slope. So slope again, rise over run. So rise is 4 because it's going up. It says rises. But then it says 2 units to the left. So we're going to put in -2. So our slope is really 4 divided by -2, which is -2. It crosses the y-axis at y equals 8. All right, well that means that our b, did I say -8? I meant 8. So our b is 8. So now we're going to put that in y equals mx plus b. And we have that y equals -2x plus 8. Okay. A line has a slope of 12 and it passes through the origin. Write the equation of the line. Well, the slope is just 12, so m is 12. And when it means the origin, that's the point 0, 0, and that means that's where it's crossing at the y-axis at y equals 0 or b equals 0. So again, when we do y equals mx plus b, we're just putting the 12 in for the m. And we don't put 0. We leave it. Okay? But normally you would put plus whatever the b is. Because it's 0, we don't write it. All right, last one. The slope of a line is 0. It passes through the point 0, -3. Interesting. Well, okay, slope is 0. And this point, 0, -3, if you just thought about it, plotting that point, the x is 0, so we're not going left or right, and you're going down 3. So this is the point 0, -3, and that represents the place where the line crosses the y-axis, which is called the y-intercept. So our b is -3. Now if we put this all together into an equation, y equals mx plus b, we get that 0 times x minus 3. So I know it says plus b, but in this case it's plus a minus, which makes it a minus. All right. 0 times anything is just 0. And this then just simplifies to y equals -3. Okay? A slope of 0 is a horizontal line, and y equals -3 represents a horizontal line that crosses the y-axis at -3. All right, let's keep going. Determine the equation of the line. All right, well, I can do what I normally do to find the slope, which is count. But remember, I have to trace along here and find a spot where the line crosses at the intersection of the grid line. So I can see that's a good spot to pick. And as I continue along this line, this is also a good spot to pick. So let me just draw my triangle. I'm going to go up and left. All right, so I went up and left. So I'm going 1, 2, 3 units up. So I'm going to say m is equal to +3 over -1 because I went left 1 unit. So m equals -3. And I'm just going to double check that each square is worth 1. Indeed it is. So my slope is -3. That's good. And my b, which is my y-intercept, I just visualize and I can see that this line crosses the y-axis. This is the y-axis. This is my line. Crosses at -1. So my y-intercept is -1. So I think I've got some, down here you can fill in -3 for m, -1 for b, and then the equation would just be y equals mx plus b, so -3x minus 1. All right, last question. The graph on the left here shows the speed of the cars on a roller coaster once the brakes are applied. So this is the speed, this is the dependent variable, time is the independent variable. So we need to find the change in the y's over the change in the x's, or we're just going to count. Now as I go along my line here, I got to make sure that one doesn't look like it's right at the grid line. I think the only spot where they're really at an intersection of a grid line is here and here. So I'm going to go ahead and draw my triangle. So up from here, or I could have started here and gone down, it doesn't matter. I'm going all the way up to the height of my other point, and yikes, I'm going left. Okay, so up is positive, left is negative. So I've gone up. Let's see, each of these squares is worth 2. I know I started at 0 and I know I ended at 18. So my m is going to be, I'm just going to write here, 18. And my run is going to be 1, 2, 3, 4, 5, because I can see that each square is worth 1. I'm going left, so it's -5. So it doesn't get reduced. 18 over -5 can't be reduced, so I can just write that. And you can put the negative in front. It doesn't really matter whether it's attached to the 18, whether it's attached to the 5, or whether it's straight out in front of the fraction, but it can't be in the top and the bottom, because that negative divided by a negative is a positive. All right, so what does the slope represent? So it's the steepness of a line for sure, but because this is a real life problem where the y's represent speed and the x's represent time, we're going to say that we're going to think about what this slope represents. So what's happening, it's the y's are increasing when the time is decreasing, or you could think of it the other way. The speed, as we go along here, the speed is decreasing as the time is increasing. So you could say, what does the slope represent? The speed is decreasing by how much? By 18 meters per second every 5 seconds. So on top here, this is meters per second. This was the y's here, and then the bottom was seconds, right? So the negative represents decreasing, and the speed then, this speed is decreasing by 18 meters per second every 5 seconds. If you had divided 18 by 5 and gotten just one number, then you would have said the speed is decreasing by whatever that was, 3 point something, every 1 second, okay? But I just left it. I didn't bother to figure out what 18 divided by 5 was. I just left it, and I just said this is the speed and this is the time. So what is the y-intercept? Of course, that's where the line crosses or touches the y-axis, so that's 18 in this case. And what does the y-intercept represent? The y-intercept represents the speed, but when? When time is 0. And another good way to say that is it represents the initial speed of the cars. Okay? All right. So what is the initial speed of the cars? The initial speed of the cars, let's just put that in 18 meters per second. All right. Write an equation that represents the speed of the cars on a roller coaster. Well, I'm just going to write the equation that represents this line. So we know the slope. We figured that out. It was negative 18 over 5. And we're going to have an x there. And then we're going to actually add our y-intercept, which we decided was 18. Okay? And that's it. I know that's tough. That's a real life word problem that relates to slope and y-intercept. And I know it's not an easy question, but see if you can do the one. I know you have one in your textbook to do. All right, so that's the end of the lesson. Please do your consolidate for 3.2 and 3.1 if you didn't do it yesterday, please. And you're going to also do some textbook work, page 115, questions 1, 2, 3, 4, 5, 6a, b, and 7. So get to work on all of that. Please put your consolidates on my desk when you're finished. Thank you.